Hello student, today we will discuss about the distillation column. So basically what is distillation? Uh, it is the simply it is a mass transfer or a preferential separation technique of various mixture based on their relative volatility. So we can do the distillation operation by using distillation column. So in distillation column we have a various components. So first component is your column in which trays or you can use pack material, and there is a one condenser, there is a one reboiler. So basically how it works. So when we enter the feed in a distillation column, suppose it is a subcooled liquid, so it will just goes down and it will just come contact in a partial reboiler. So what is the purpose of partial reboiler? In partial reboiler we are using steam. So when this component will come in indirect contact of partial reboiler, then the portion of the mixture will get vaporized. When it will get vaporized, after some time you will see in the top section of the column there is a lot of more volatile component. So the section above the feed line, known as the rectifying section, this part, and the section below the feed line is known as a stripping section, in which less volatile component is more in a vapor is and in a liquid is in, in a liquid and in a vapor. It is a liquid, it is a vapor, it is a vapor, it is a liquid. So basically what is the purpose of total condenser? Suppose when the more volatile component in a vapor form come in a total condenser, so the purpose of condenser to condense all of its vapor. Generally in the industry we use total condenser. So it will collected in a reflux drum. So sometime uh, on the basis of their requirement they distill out whole product, but sometime we reflux back some of the portion of distillate, which is mentioned here as a L. What is the purpose of reflux? To get more purity in the product. So we can define also a reflux ratio. R barabar L by D. What is L? Some portion of the distillate which is fed back to the column divided by distillates or top product. It is a reflux ratio for the rectifying section. R barabar L by D. It is for rectifying section. Similarly, we can define it for a stripping section also. What? Refract ratio for stripping section is V by W. The bottom product, W is the bottom product. V, which is fed back to the column. At bottom. Divide by W. It is also known as the boil up ratio. Boil up ratio. It is also known as a boil up ratio. So here we can define a reflux ratio for a rectifying section R barabar L by D, as well as we can define reflux ratio for stripping section V by W, boil up ratio. It is also known as a boil up ratio. So sometime interviewer you can ask the question, what is the duty of total condenser? So in condenser we generally use cooling water. Sometime in various industry we are also using chiller or coolant, but generally we use cooling water. So how much the you require the cooling water for condense this vapor is known as a duty of condenser. And similarly, they can ask about what is the duty of partial reboiler. So how much steam is required to vaporize the portion of mixture as required. So duty of partial reboiler, how much steam you required in a reboiler to perform the particular separation as per your requirement. So now we will just come on the part of material balance. Suppose your feed is F mole per hour and having ZF, it is nothing but the mole fraction of the more volatile component in the feed. And what is XD? XD is nothing but mole fraction of more volatile component in top product. XW, XW is XW is XW is it is the mole fraction of more volatile component in bottom product. So now you can do the material balance. Suppose we are just drawing this envelope. We are drawing this envelope. Now we will do the material balance along this envelope. So here the portion of D mole per hour. We drawn the distillate D mole per hour, and from nth tray the liquid with flow rate Ln, it just it is coming out from this tray Ln, and the vapor from n plus 1 tray is going towards nth plate with rate V n plus 1 mole per hour, and having the mole fraction of more volatile yn plus 1. So now if Ln plus, if we are considering the flow rate of the liquid and the vapor is same across the column, like Ln plus 1 barabar Ln barabar L, Vn plus equal to Vn equal to V. So we can say V is equal to L by D. We can say V, which is going inside, it is coming out and it is coming out. So V is equal to L plus D. And from the above relation we know that L is equal to RD. So we just put the value of L RD here. You can see here V is equal to D R plus 1. Now we will do the component balance. V into Yn plus 1 equal Lxn plus Dxd. What is Yn plus 1? It is the mole fraction of more volatile component in a vapor state, which is coming out from n plus 1 tray. Xn is the mole fraction of more volatile component in liquid state, which is coming out from n tray. And D, distillate top product. Xd, mole fraction of distillate, this one. So now what will you do? We will just do the some mathematical calculation. Yn plus 1, we are just L by V xn plus D by V xd. Now we will divide numerator and denominator by D. L by D, V by D, D by D, V by D. Now we will get, we know that L by D is equal to R from this equation. So we will put R. V is equal to D R plus 1. We just put here D R plus 1 divided by D. D by D is equal to 1. V is equal to D R plus 1. We just put here and divide by D into XD. Now this equation which is coming out is known as a operating line equation of rectifying section. yn plus 1 is equal to r plus 1 xn plus 1 by r plus 1 into xd. You can compare it with the state line equation y barabar mx plus c. M is equal to here r plus 1 c xd divided by r plus 1. Hope it is clear all of you. Thank you.